we're here to talk about soil forming factors, and one of the key things in this part of the world is the glaciation and glacial lake peace. I'll talk a little bit about fire effects and its effects on the soil landscapes that we have, and some of the interesting things that we learned from the original land survey mapping that was done in the Peace region. And then Sandy will talk about soil types and factors and improving soils and positive changes of management, some of the experience that she's had in working with producers over the time that we've lived here. So as we all know, the Peace region is a very large region. I think you can see the agricultural areas centered along the Peace River and going north towards Manning and Lacrete in this image. And so it's a huge region with a great deal of variety. The Geological Survey of Canada were actually some of the first surveyors in this area, and George Dawson, when he came through this area in 1787, through what is now Dawson Creek and on his way to Dunvegan, he consistently reported about the soils that he observed in the area and talked about their agricultural potential. That was one of the key things that he was supposed to do in his work. And as a result, this is a map from 1911. It's a guide map to Peace River land seekers and settlers. It's focused on the British Columbia side of the border. And what's really obvious in this are you see the prairies, Pouce Coupe Prairie, Lone Prairie, Barrel Prairie, Rose Prairie, and then going further north, open prairie and prairie lands. And in fine print on this image that's interposed are phrases like fine land, poplar bluffs, soil rich, prairie and park, good soil. So these are all the reasons that we came to the Peace. There's good land here, and you can do good things with it. The soil forming factors that we need to consider, and we start with that parent material. So in this part of the world, what did the glaciers give us? They laid that foundation, and soil processes have happened on that land. Also, with the glaciers and the things that went on with the glaciers that we'll talk about, there's topography and drainage, the landforms. And after the glaciers left, we've had thousands of years of living organisms interacting with that soil and the climate that we have here in the Peace over thousands of years. And then more recently, we've had that extra addition, humans and what they manage and what they do on that soil landscape that's been forming over thousands of years. Again, the key thing that's different about Canada compared to many places in the world is our history of glaciation. So numerous times over millions of years we've had glaciers. And so now we're just going to do the last 50,000 years in 3 slides. So hang on. The Laurentide ice sheet, that's the large ice sheets that formed in the continent, somewhere near Hudson's Bay, and over thousands of years. Again, we always have to keep that in mind. Thousands of years, that ice sheet expanded. And we also had glaciers forming out of the Rocky Mountains and advancing out of the Rocky Mountains. And they literally met right around Fort St. John. So that top image, about 18,000 years ago, the Laurentide ice sheet had expanded to its maximum extent, and the Cordilleran ice sheet expanded out of the Rocky Mountains, and they met around Fort St. John, and that really shapes a lot of the things that we see. The lower part of that image, around 11,000 years ago, those glaciers were retreating, and there was a corridor that linked areas up in Alaska, which never did get glaciated. Parts of Yukon and Alaska didn't have that most recent glaciation, with areas south of the 49th parallel that again were never glaciated. And that number 2 with the red circle is again approximately where Fort St. John is. So 11,000 years ago, there was a land corridor in between those 2 glaciers. And we know, for example, that First Nations were living in the Charlie Lake caves, and there was wildlife, they were successful hunters, vegetation, things like that were already happening 11,000 years ago. And with those 2 glaciers, this is a close-up, again on the British Columbia side from the Soils Report in 1965, summarizing things. So the yellow are the glaciers that came from the continent. So huge masses of ice, bigger than we can imagine. When we see the Athabasca Glacier, on a holiday, that doesn't compare to what was happening here thousands of years ago. So these huge masses of ice slowly over thousands of years grinding their way across the Canadian Shield. Lots of granites and things like that, relatively nutrient poor, relatively acidic parent materials pushing this way. Then out of the Rocky Mountains, we have glaciers that are pushing out of the Rockies, which have a lot of limestone and calcium and magnesium rich soils pushing out, and again, meeting right around Fort St. John. So these two things met, and then they retreated. And almost like a dance, again, it's not A, B, and C, that continental glacier, the Laurentide ice sheet, came forward and back and forward and back several times. So if you took social dancing in high school, you know the idea about forward and back and meeting your partner. As those glaciers melted, a lot of water poured out of the Rockies. And in this image, but it took thousands of years for it to retreat. So you can see that big ice blob in the corner of that image. You can see the blue of these huge lakes. And these lakes were around for thousands of years. It wasn't a fast thing, it wasn't a one-time thing. And again, they were higher and lower depending on the timing. And out of the Rockies, so drainages like the Halfway River, the Peace River, a lot of water was pouring out, and it meets this huge ice dam, which became Glacial Lake Peace. Around the Grand Prairie area, the Wapiti River, the Smoky River, again, more water than we can imagine. Enormous rivers, much bigger than the ones that we see today, were pouring out and meeting this big dam and forming a lake. And in that lake, the fine textured clay and silt particles settled out 50 and 100 meters deep. Then, over thousands of years, 10 to 15,000 years ago, as the glaciers retreated, all of that water coming out of the Rockies is cutting down through 50 to 100 meters of lake sediment settled in some areas, and those slopes are unstable. So for thousands of years, we've had the land rearranging itself and settling and slumping. And this is an image courtesy of Arthur Hadland of the slide near the Halfway River. So near the top end of that image, the Halfway River is joining the Peace, and just a little bit in the foreground, the land slumped, and it slumped so in such a large quantity of material that it actually dammed the Peace River for about 8 hours in 1973, and all along the major river systems, the Beaton, the Halfway, the Peace River, you can find that land slumping. So that's been an active soil forming process for thousands of years. Now, if you come and talk to me this afternoon, I'll tell you a very entertaining story involving gold and fur traders and prospectors and slumps. Fire history. So again, 10 to 15,000 years ago, vegetation was here, animals were here, and in the forested areas of the Peace forming soils were wildfires. In the brief time that we're here with you this morning, the main idea I want to leave behind you is the variability. Okay, we talk about forest fires, and we might have an image of a wall of flame, as you see in that one picture, but in a lot of ways, they skip around. There's areas that are burned and unburned, and whether it's a scale of 1 meter over here is burned and this is completely untouched, or 10 or 20 meters like you see in that image, or 100 meters. So there's a lot of variability in how much it burns and where it burns when we use the term forest fire, and in the forested parts of the Peace that affected our vegetation. So you go from where there's living plant material, maybe some dead standing trees, down wood, the organic material that's collected in a forest, and then depending on the fire, spring fire, fall fire, really hot fire, all of these things can vary what actually happens. It may burn all the way down to mineral soil. It may just lightly scorch things and kill things. It may consume some of the down wood. Again, a whole variety of conditions can happen in the fire. Those flecks rising out of the smoke column, one of the important aspects is depending on that fire characteristic, you can lose particularly nitrogen, whether it's in wood ash that's blown off of the forest fire, or even in chemical combustion that changes forms of nitrogen into gases that escape the system, and then you need time to gradually recover and rebuild those organic matter and nutrient stocks. So another thing to keep in mind, when we drive through a landscape, is how things have changed with time. And certainly First Nations, for all the time that they were here, they used fire to manipulate their landscape and create the kind of landscape that they wanted. What I'm going to use in this presentation are published literature, which is incomplete because it doesn't incorporate First Nations traditional knowledge. But there's a wonderful article, The Careless Fires and Smoky Weather. A woman named Teresa Ferguson looked at the Hudson's Bay trading journals from 1880 to about 1899 and recorded all the incidences of fire. So that upper little blurb, so on May 10th, 1842, outside of one of the Hudson's Bay forts, they sent Jean Vienne to burn the old grass in the meadows where we get our hay made generally. So using fire on purpose to do certain things on the landscape has a long tradition. And this image is from a ranch in the Peace River Valley about 1916. And I apologize for the quality, but the burned open slopes and the burned tree in the foreground, again, give you an idea of how fire had been used in that particular area. We also have soils that developed under grasslands in the Peace. And one of the best tools that you can use to sort that out, and the people have used in the past, is the soil maps. So soils developing under grasslands give you different characteristics than the ones that developed under forest cover, and on those boundaries of where the prairies met the parkland, again, that's where people often used fire to create the particular conditions that they want and push that boundary back and forth. A source of some of the information are the original land surveyors. They had to, as they were surveying the land into different sizes of parcels and forming boundaries, or make notes of exactly what vegetation was present when they were doing that work. This is from a master's thesis on the Alberta side. So you can see Grand Prairie near the bottom, Peace River up on the top of that image. And so what Kathleen Wilkinson did was take those old land survey records and put together where did they record natural prairies and open woodland. So the darker portions of that black and white image around Grand Prairie, around Spirit River, around Fairview, around Grimshaw are where these natural open areas were found. And that's what Stevenson used in 1911 to create his map to attract people up here for agricultural purposes. So if you'd like more information, here are some examples of really interesting surveying and exploring this part of the world earlier on, the history of the Denisah people, summarized by the Riddington family, and the Chinchaga firestorm, when the moon and the sun turned blue. So, Mr. Lehman, one of your claims to fame, the largest fire recorded in British Columbia history started near Cecil Lake in 1950. So it started there in the spring of 1950, went across the border into Alberta, and parts of it burned all the way up into the Northwest Territories by October. That was about 1.4 million acres. There was smoke in New York City, and the skies turned blue over Scotland. The Donnie Creek Fire 2023 near Fort Nelson and so on was about 500,000 acres, so roughly 1/3 the size of that fire event. So we have an interesting history about what has happened on these landscapes. Again, back to our soil forming factors. Try to very, very quickly talk about parent materials, topography and drainage, our living organisms, the climate that we've been in, and the thousands of years that those soils have developed, and the humans and their management with the more recent influences. This is a very high-level satellite summary of the variety of soils that we have in the Peace River area. The yellow ones are a certain type of soil, which Sandy will talk about. And then there's soils that developed under grasslands. But in Canada, the entire country, at this level, soil orders, there are 9 soil orders, and in this image, 8 of those 9 soil orders are found. So we have tremendous variety of soil types in the piece, and again, that's an advantage and something that we can learn from. So my joke yesterday was that I dig a hole and now Sandy, the real soil scientist, gets us out of it. Yeah.
So is this turned on? So just as a warning, we took a number of sabbaticals with our children, and when we were driving across Canada, we heard our kids talking in the back seat, is this a mom week or a dad week? Because on the dad weeks, we knew where exactly we were staying, where we were going to buy groceries, where they were going to hand in their schoolwork. But if it was a mom week, we were going to make it up as we went along. So just a warning for this part of the presentation. So this first, so we went from Rick's satellite view of the piece and all the soil. Think about that. 8 of the 9 soil orders used to describe soils right across Canada, 8 of the 9 occur in the piece. Oh my goodness. And as we drop down in elevation, now we're at kind of a jet coming into Fort St. John level. And this is from so that we can get into the detail, but it applies to all the landscapes right through Alberta. But we're just going to use some examples here close at hand so we can get into that detail and see if you can relate to it. So this map was from a project called Soil Health Matters in Rose Prairie in 2021, and it's courtesy of the Blackbird team right here in the front. Thank you. It's always fun to work with these guys. And 5 or 6, no, maybe more, like 7 or 8 of the cooperators in the room can find their farm on this map. And then what Matthias or Aaron, I don't know which of you did this for us, but we have a number of these over the years that have been compiled by Blackbird. They took a cross-section of the elevation so that we could start to see how these soils occur in different parts of the landscape. And so at the far left, you have the upland soils, things like Alcan. When I say Alcan, it was named after the Alaska Highway. But you can find Alcan soils in Alberta. We found them on the Spirit River map. So when we say those soil names, it's where they were first encountered and very typical examples. So another example, we'll talk about falaire soils, and that would be relevant to some of the speakers that were just up. That first was described in detail from, around falaire or Nampa. We have Nampa soils right along the east part of our BC piece. And then going into so the upland soils or the Alcans are the green, and we're going to really get looking below the surface in a minute. But just an overview, and then of all the soils we could talk about, we're just going to zero down into 3, because they give you a good idea of how it changes over the landscape. There's a lot of blue areas, and those would have been from when the glaciers slowed down. They were dammed by glacial lake Peace, and so that's when the clays were deposited in the silts. So they're old lake bottoms. The bright yellow would be the undifferentiated slumping soils around the melt channels, like the Beaton here and the Doig. And then we were going to talk about a poorly drained soil right down in the lowest parts of all the landscapes, no matter whether you're on glacial till or lacustrine. So you've already used more words than I had hoped I would, more terminology. And so soil scientists have ways they designate the horizons, and it feels like a whole new language and all this memorization. which is myth number 2, and I wanted to show myth number 1 first. Rick and I get repeatedly asked when they look at a profile like this, is that an ash layer? Is that from fire? No, that is not. That is from the processes going on in that profile. So, and then myth number 2, what I jumped in ahead of time, is it's not memorization. It's about understanding the processes, what's naturally there, because you can go in and change it with your management, but these processes that are happening on your soil, they've been doing that for 1,000 years, and they're going to keep doing it. So, as Rick was talking about the glaciation, there's the effects of parent material. And that can be important for texture and pH, even though it's way down. You know, the parent material is often a meter more down. It's going to percolate up. And then Rick gave an overview of the effects of vegetation and landscape, slope, and drainage. So for this first upland soil, we're talking about a soil where water is running off it for the most part. But then you also have water percolating down through the profile. So moisture is going down through that bleached layer that looks like ash, taking clay with it, taking nutrients with it. They're often lower pH, and they're left with not much aggregation after that process. So here we are again, and I'm going to name drop. Think of these. Think of this term. You throw 3 terms at you, but think of the Luvasols as like a family reunion, and so there's going to be all these personalities there: the Alcan soils, the Murdale, Dixonville, Braeburn. You know, those would be names from Alberta soils. So they're relevant to both the Alberta and BC piece, and some of the example cooperators that I've worked with are listed there. And remember, I said the moisture is moving down through the profile. It's taking clay and nutrients with it and organic matter. And so the way the soil shows you that this is happening is there's little dark clay stainings on the PEDs. And so think about that bleached layer. Now many of these areas were cleared and plowed, and that can bring up those layers to the surface. So this was when we worked with Rob Larson, and he had an area of his pasture that after many years he still could not get back into legumes, because if you look at the pHs, the pH in the surface, the AH layer when it's undisturbed was 6.8, and the lower layer, that bleached layer, was 5.1. So bringing that to the surface really kiboshed him establishing legumes there. And I'm going to show a number of these examples of our soil quality work, and the colorful part is Dr. Bill McGill from UNBC and I took the numbers and did literature searches and compiled ranges so that you knew as a farmer whether that number, what did that number mean? Is it poor? Is it kind of warning you, or is it good? Good, you're good to go. And we could talk about pH a lot in this area, but you had a good station yesterday with the Ag Canada people, and they're still here today, so I'm going to leave that for them. And introduce you to another family reunion. So at this family reunion, there were Doig soils, Rossland, Escher, Falher, Grimshaw, Rycroft, and Megan brought 2 lovely soil profiles, monoliths down from Manning, and they were good examples of this kind of soil. So come see us at our station. We kept the monoliths here. So what's happening in these, first of all, vegetation-wise, they are developed under grasslands. And parent material-wise, they're developed on those slow-moving waters, those heavier clays, those glacial lacustrine. And the processes that are happening in this soil, because that's what this profile, you can learn to know this for yourself, what this profile is telling us. This is near Rolla, grassland that had never been cultivated. But you can get the moisture moving up and down. So it starts out moving down like the Luvisols, but then in times of drought or just they're in warmer areas, evapotranspiration, you have salts moving up and down through the profile. And the nasty one, not only magnesium, as one of the speakers talked about this morning, but I would urge you to add sodium into those chemical analysis that you're looking at, because what happens is the sodium comes up, interacts with the clay, and actually breaks the clay and disperses it, and then they reform into these hard columnar-like structures. Break your shovel, Fred, type structures. And I think this is important in the conversations about compaction. You got these gifts from the glaciers that are your starting point. So just knowing about those hard columnar structures, poor infiltration, adverse soil fertility can be very high sodium and magnesium. And so then some of the producers that we worked with on these soils, we worked with Heather Fossum and her family, and she was trying bale grazing because she wanted to get more organic matter to mitigate those negative effects. And so we measured about 15 properties, but I'm just showing glimpses of these soil quality report cards. So I'm just showing you here the organic matter. So you can see in the first green area, they're both in green, but you can see that that adding the bale grazing has increased the organic matter. And Heather was really interested in the soil respiration measurements that we took in the field, and had really increased the biological activity under the bale grazing where it had been, and increased the rooting depth. And another cooperator that we worked with was Les and Hannah Wilms, and they're again on these challenging soils. They were very concerned about this compaction. They wanted to break that up, increase the water infiltration into their soil, and increase the storage capacity after they got the water in. And so they wanted to use plants, and specifically cover cropping, and you've got a speaker later on to tell you more about that. They were asked to speak at on a panel down at in the Lower Mainland for farm folk, city folk. So, wow, we had producers representing us well, representing our area. And if you just look before I speed on to the next slide at how that the turnip and radish roots were able to penetrate through the compaction and start forming better aggregates. Pretty exciting, hey? What producers can do. Okay, one more family reunion to take you to. And all your landscapes, no matter where you are in the piece, and no matter whether you're on lacustrine or till, will have those little low areas where the water is at the wrong place in the wrong time. So they're the lower parts of the fields, the lower parts of the landscape. I can see people starting to shake their head. Yeah, that's one of my challenges. And the way the soil tells us this secret is, again, another kind of gray, but it's called glaying. So you can see that horizon on the left is quite grayish and glayed, and that shows you that the water's been in that profile for a certain amount of time, weeks, not just days, and the chemistry, they're all in the reduced forms. And then this is another example on the right-hand side, and there's been water move up into that profile and sit for a while, but then, and so there was some reduced and glaying, and then it drained back out and it left the oxidized versions, or those rusty versions. So whenever we see that kind of blotching and mottling in the soil, no matter what anyone tells us, we know that that's been, ponding for a certain amount, or, the water, poor drainage. Sometimes there can be a thick peaty layer like on the right that requires special management. And in summary, this can be moisture at the wrong place at the wrong time for plants. So working with Tara Holmes and Ben Harrington, these are the original visits to your farm in 2017. And they had a pen that they called the chamomile pen, and it had been, they'll correct me if I'm wrong later, catch up to them. It had been overgrazed and compacted, and there was bare spots, and of course, chamomile said, woohoo, bare spots, and in came the chamomile. And there was a field next to it that they wanted to do more of on their land, where they were using rotational grazing and thinking about keeping their organic matter intact as much as they could. An interesting sidebar is we resampled these areas in 2021, and they were having so much success with their new ways of looking at things. They were starting to manage that chamomile pen differently, and it was starting to change and improve. But anyway, going back to the original visit, organic matter was much improved, and this was reflected in the available water holding capacity. So I want to talk about this property a little bit because we're in a drought, and because I'm really hoping that the Ag Canada researchers will find a way to include this property. I know you can't do all soil properties, but man, is this one important for droughty soils like we have here. And you have such a network. There must be some, just like you have Denis doing GIS work for you, there must be an enthusiast in your network somewhere that you could entice to do available water holding capacity for these producers. So water holding capacity is different from soil moisture, another myth. So soil moisture can be pretty well anywhere on that graph. But what I want to focus your attention on is water where you are on that graph. So in the lower corner, the lower right-hand corner, and there's a line going up, that's the wilting point. When your soils are at that wilting point, and it's different for different textures, once it stayed there with no rain for 2 weeks, and if you're down there, the plants have different tolerances, so it might be different places, but they're going to say, too late, you can't revive me. And then if you go up to the upper line, that represents where the soil pores are so full of water that it's starting to run off and erode your land. So that's not good either. So what you want is the moisture in between those two lines, the available water. So when I say available water, that's what we're talking about. And available water holding capacity is like having your moisture at the right place at the right time. And I just was showing, I guess this line was showing the maximum is not clay. We think, oh, the more clay, the more moisture. Yeah, but how much is available? So the best in terms of available water holding capacity are the loams right in the middle of the graph. Here's the same story said in another way. So you can see the textures across the bottom, sand at the far left, right down to clay loam. And I added some producers so they could see where they were at. And you can see that the red is the non-available water. So factors that you can't change. You can't change the precipitation in the water that's going into the soil. And you can't really change the capillary rise, although with good plant health you could, maybe a little bit. Soil texture you can't change. Sorry, that's gifts from the glacier, and that's really hard to move your soil texture. And Dr. Bill McGill and I wrote this all up if you'd like to read more in a forage fact that's available on the Peace River Forage Association's website. Now here's something you can do, and I want to show you how important soil organic matter is. So on the bottom of the graph is increasing your soil organic matter, and moving up the graph for different soil depths is how you can increase your available water holding capacity. So for every 1% increase in soil organic matter, you're adding almost 0.2 inches of available water per foot of soil. That doesn't sound like very much, but remember that previous graph where some of your available water holding capacity was only 1.5 or 2, so it's significant. So the factors you can change are snow retention, runoff, infiltration, aggregation, and pore size, soil organic matter. So the bottom three that are starred are being measured currently in the Peace Region Living Labs. And here's, I've worked with so many producers over the years, and I would have liked to feature them all. But anyway, here's 4 more that I worked with and what they were doing to try and increase their organic matter and their available water holding capacity. With bale grazing, winter feeding, composting, we had a project where we produced topsoil, basically, and were able to improve the available water holding capacity when it was applied on the forage field. If you'd like to talk more about this, we really enjoyed our conversations yesterday, and if any of you would like to talk more, we have a learning station this afternoon. Rick and I have been asked to do a soil landscape of the Peace Field Day course, and it just happens year to year, but we just figured out it's happened for the last 15 years, so we don't know who will host it this year, but probably it'll happen again. And in the lower picture, you might see Matthias in there, Keith Carroll, Julie Robinson. We've collaborated with some great people over the years. And I'd like to thank all the innovative cooperators that I've worked with over the years. Really, over and over, you're an inspiration. So thank you.